So I hope you had a chance to watch some of the videos from YouTube on free radical polymerization, just to get a scope of what these types of reactions are and why they're so important. Those videos didn't really show you the mechanisms of the reactions, so I thought that I would do that here for you. So I'm going to be looking at the free radical polymerization of styrene. This is styrene. There are three different ways that you can represent styrene, just depending on what it is that you're trying to show. In this free radical polymerization, you have the same kinds of peroxide initiators that you saw when you were adding HBr, HCl in the presence of peroxides to a carbon-carbon double bond. So for instance, in this reaction, you're starting off with some number of polystyrene molecules. So there's a lot of polystyrene. There's only a little bit of the initiator. So the free radicals are generated once again by either heating or shining ultraviolet light on the peroxide, and you get two free radical initiators. So now the free radical is going to initiate the reaction by reacting with the styrene molecule. The one electron from the oxygen is going to react with one electron from the from the styrene, and then one electron stays on one of the carbons, so that there are two possible intermediates that you can get in this initiation step. In one of them, the RO will be bonded to carbon 1, and I can just label these carbons. If the oxygen is bonded to carbon 1, then carbon 2 is the carbon that didn't do the bonding, and it gets the unpaired electron. Or the oxygen can bond to carbon 2, and the free radical will end up on carbon 1. When you look at these two species, the one on the left is stabilized by resonance. Remember that free radicals are electron deficient species, just like carbocations. What you should do on your own is take the time to show at least some of the resonance structures for this intermediate. You may have to do this on the exam. So this was the initiation step. The next step is going to be a propagation step. So in the propagation step, now the free radical is going to react with another styrene molecule, the unpaired electron will react with one of the electrons in the pi bond. The other electron in the pi bond will once again go to carbon 2. So if I'm continuing to number these, actually I should use different numbers. So this was 1 and 2, now this is 2 or 3 and 4. So now I have my original molecule. Oh, I need more room, sorry. So now I have my original molecule with carbons 1 and 2. I have a new bond between carbon 2 and 3. 3 is still bonded to 4. And 4 is still bonded to the phenyl group. The unpaired electron is now on carbon 4. This will react with another phenyl group, another styrene molecule, in the same kind of step. So these are propagation. So what you end up with is a polymer that looks like this. So here is the original . It is bonded to one styrene, which is bonded to another styrene, which is bonded to another styrene. So that when you look at the carbons that comprised each of the monomers, there was the first styrene. Here's the second. Here is the third. Here is the fourth. And the free radical would be there. This will keep going as long as it doesn't get terminated. Remember that the termination is when two free radicals combine. There are other termination steps, but we're not going to really study those. So if you look at a termination step, for instance, this is the growing polymer, and I have a free radical. It could encounter a free radical of another growing polymer and terminate, or it could encounter an RO free radical. That would be a termination step. Generally, when you see these kinds of polymers written out, they leave out the initiator and just show kind of the repeat unit. So the repeat unit in this case looks like that. This is polystyrene. Hopefully you had a chance to see some of the other really important types of polymers that are made this way on some of the other videos.